My dear students, I hope that you are fine and well. Today I am going to continue the next topic from the chapter Coordination Compounds of class 12. In my previous video I have taught you about the types of the ligands. So today again I will continue. So the next is ambidentate ligands. So ambidentate ligands has the two different donating sites atom, but any one donating sites will donate at the time. It means the ambidentate ligands, it has the two donating sites, but only one donating sites donate the lone pair of electron to the center metal. Okay, like example is NO2 minus, Cn minus and SCN minus. So first is Cn minus. Here we can see this Cn minus has the one lone pair of electrons. So here it is when carbon donate the electrons to the metal, that is known as cyno, and when nitrogen donate the electron to the center metal, that is known as the isocyno. So here both carbon and nitrogen center can donate electrons, but one at a time. It means carbon and nitrogen can donate the electron, but at a time only one will donate the electron to the central atom. Mainly carbon has more tendency to donate the electron than nitrogen, because nitrogen is more electronegative than carbon, so nitrogen will hold electrons. It means carbon can easily donate the electrons than that of nitrogen, because the electronegativity of nitrogen is more than that of carbon. So electronegativity means the electron holding capacity. So nitrogen hold the electrons, its electrons very well than that of carbon. So carbon can donate the electron easily to the central atom. Okay, so here the second is nitrate, NO2 minus. So here nitrous acid convert into the nitrate ion by losing and H plus ion. So donating sites will be nitrogen and oxygen. Here it means nitrogen and oxygen both can donate the electron, but at a time only one will give the lone pair of electron to the central atom. So here the in this donating sites, nitrogen and oxygen with negative charge will donate O minus. It means nitrogen and oxygen both can donate the electrons. So here oxygen and nitrogen both are the donating sides. Here I have written. So if nitrogen will donate the electrons, that will be known as the nitrito N, or simply we can say nitro. While if oxygen will donate the electron to the central atom, then it will be known as the nitrito O, because we will write O because oxygen is donating the electron, so it will be known as the nitrito O, or simply we can say it nitrito. So here we can see that oxygen is donating the electron to the center atom, so it will be known as the nitrito O, or simply nitrito. And when nitrogen will donate the electron to the central atom, then it will be known as nitrito N, or simply nitro. Okay, so I hope that you got these points. Now here again I have taken the next example SCN minus, which is known as the thiocyanate ion. So here it is also the ambidentate ligands, and here sulfur and nitrogen both can donate the electron to the central atom. So here you can see sulfur and nitrogen both are the donor side. It means both can donate the electron to the central atom, but at a time only one will donate the electron to the central atom. Okay, it means at a time sulfur can donate the electron or nitrogen can donate the electron. Okay, so if sulfur will donate the electron to the center metal, then it will be known as the thiocyanato S. Okay, it will be written as thiocyanato S. And when nitrogen will donate the electron to the central atom, then it will be known as thiocyanato N. Clear? N means it is the electron is donated by nitrogen, and here S means the electron is donated by sulfur, which is also known as thiocyanato. S is also known as thiocyanato. And when nitrogen donates the electron to the central atom, then it is also known as the isothiocyanato. Okay, so I hope that it's clear. Now the next is chelates. What is chelates? So bidentate or polydentate ligands. Bidentate ligands means in which the two atoms donate the electron to the central atom, or two ligands donate the electron to the central atom, or polydentate ligands is known as the chelating ligands if on coordination it results in the formation of a closed or a cyclic ring structure. So here those coordination compound is known as the chelating ligands, in which they form a closed or cyclic ring structure. The complexes thus formed are called chelates, and that complex compound are called chelates. So here I have taken an example, and that is CH2, NH2, CH2, NH2, and in middle copper. The central atom is copper, and again CH2, CH2, NH2, and the whole charge is plus 2. So this is ethylene diamine, both are ethylene diamine. So here we can see that here the ethylene diamine forms a cyclic structure. You can see here a cyclic, here is also a cyclic structure, and in cyclic form they are donating the electron to the center metal, means copper. So this compound, this complex compound is known as chelates. Okay, chelates, and these ligands are known as the chelating ligands. Okay, so I hope it's clear. Now we come to the next topic, and that is coordination polyhedra. So what is coordination polyhedra? The spatial arrangement of the ligands atom which are directly attached to the central atom ion defines a coordinate polyhedra about a central atom. It means spatial arrangement means in a 3D dimensional structure of the ligand which is directly attached to the central atom or ion, which forms the coordination polyhedra. Okay, so the ligands which is surrounded around the central atom, they form a coordination polyhedra. The ions are atoms attached via secondary valency to the metal have a characteristic spatial arrangement and constitute a coordination polyhedra. So it means the ions are atoms of the ligands which is attached to the central metal, that is known as the secondary valency of the central atom, and which is um, in the coordination polyhedra. It means it is written in a square bracket. So the component which is present in square bracket, that is known as the secondary valency. Okay, next is most common coordination polyhedra are octahedral, square planar and tetrahedral. So coordination polyhedra, they show octahedral structure, square planar structure and tetrahedral structure. So here I have taken some examples, and that is CuNH3 whole 6 and the whole power is plus 3. So here we can see the 6 ligands, neutral ligands are attached to the central atom. So here its secondary valency is 6. So its structure will be octahedral and its coordination number will be 6, because 6 ligands are donating the electron to the central atom. It means 6 ligands are attached to the central atom. Now next is NiCO whole 4. So here CO is carbonyl. So here 4 carbonyl is attached to the nickel, so it forms the structure tetrahedral, and here its coordination number is 4. Next is PtCl4 and whole power is minus 2. So here the structure of this coordination compound is square planar and its coordination number will be 4. So here in a spatial arrangement we can write coordination number 6 is the ligands will be attached like this central metal, and the ligands are attached around the central metal, and it forms the structure octahedral. Next is tetrahedral, in which 4 ligands are attached to the central metal in a tetrahedral structure. You can see the 4 ligands attached like in a tetrahedrally. And the third one is which is also have the coordination number 4, and which show the square planar structure in which the 4 ligands are surrounded to the central metal, and it forms the square planar structure. And the next is coordination number, some coordination compounds, so the coordination number 5, and here they form the trigonal bipyramidal. Okay, and next is square pyramidal structure. So here the same coordination number 5, so in this case it forms the square pyramidal structure. Okay, so we can say that if the coordination compound have the secondary valency of 4, it forms the 2 structure tetrahedral and square planar, while if its coordination number is 5, then it has also the 2 structure trigonal bipyramidal and square pyramidal. Okay, so I hope that you got these points very well. In my next video I will explain the next topic, so you all must subscribe my channel, and if you have any doubt you can comment in my comment section. Sure, I will reply you. So thanks and have a good day.